Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Cation I, benzylic carbocation, Ph-CH2+. The positive charge is on a primary carbon directly attached to a benzene ring. The empty p orbital overlaps with the pi system of the aromatic ring, allowing extensive resonance stabilization over 7 atoms, 6 ring carbons plus the exocyclic carbon. This is a highly stabilized carbocation. Cation II, H to C is equal to CH, CH2, CH, plus CH3. The positive charge is on C2, a secondary carbon, and there is a vinyl group at C4, separated by a CH2 at C3. The double bond is not directly adjacent to the carbocation center. There is a saturated CH2 group between the cationic center and the double bond. Therefore, there is no homoallyl or allylic resonance stabilization of the cationic center. The only stabilization comes from the inductive effect of the secondary carbon to alkyl groups. This is essentially a secondary carbocation with no special resonance stabilization. Cation III, H3C, C, CH3, 2CH2+. The positive charge is on a primary carbon, CH2+, adjacent to a quaternary carbon C, CH3, 3. Although it is a primary carbocation, it benefits from hyperconjugation and inductive electron donation from the 3 methyl groups on the adjacent quaternary carbon. This provides more stabilization than a simple primary carbocation and can be considered comparable to or slightly better than a simple secondary carbocation due to the multiple hyperconjugative interactions from the 3 methyl groups on the beta carbon. Moving on to the next step. Cation I, benzylic resonance stabilized over the entire aromatic ring. Very stable. Ranked first, Cation III. Primary but with quaternary beta-carbon hyperconjugative stabilization from 3 methyl groups. More stable than Cation II. Cation II, secondary but isolated from double bond only secondary alkyl stabilization, no resonance with the distant double bond. Ranked third. And for the final step. I3-2. But the correct answer given is A, I2-3. Re-evaluating Cation II, H to C is equal to CH, CH2, CH, plus CH3. Looking more carefully, the structure is a secondary carbocation at C4 of pent 1N4 vial system or similar. If the charge is on carbon 2 and the double bond is between C4, C5 with CH2 at C3, there is no direct resonance. However, if we reconsider, the structure H to C is equal to CH, CH2, CH, plus CH3 has the cation as secondary, 2 carbons attached, CH2, CH2 is equal to CH2 chain and CH3. A secondary carbocation is generally more stable than a primary carbocation. Cation III is primary, CH2+, and even with hyperconjugation from a quaternary neighbor, a secondary carbocation typically ranks above a primary one in standard comparisons. Thus, I, benzylic resonance, 2, secondary, no special resonance, 3, primary with hyperconjugation. This matches answer A. Why other options fail? B. To 3I, incorrect, benzylic cation I is far more stable than secondary cation II. C. 3I2, incorrect, a primary carbocation cannot be more stable than a benzylic cation. D. I3-2 would be correct if hyperconjugation of 3 outweighed secondary stabilization of 2, but standard carbocation stability ranks secondary above primary regardless of beta substitution in most textbook treatments. Therefore, the correct answer is A. Therefore, the correct answer is option A.